Okay, so again, in lesson 1 here in module 2, we're talking about transformations. When things are transformed, they're changed. And the one we're going to be kind of focusing on right now is congruence, right? Things are not getting any bigger or smaller. So maybe we need to make sure we understand that word. Okay? It says congruence refers to whether or not a figure has the same size and shape after a transformation. Okay, so congruence really is our geometry word for in algebra, what we refer to as things are equal, right? Not getting any bigger, any smaller. Okay, so if it has the same shape and size, it's congruent. Now, the orientation of the figure refers to, if I can spell correctly here, refers to whether or not the figure is facing the same direction, okay, on the coordinate plane after transformation. Okay, so did it flip around? Okay, kind of think about it. We'll talk about this in a little bit. If things slide, they're not changing the way they're facing, okay? But if we flip them, they are, okay? Now, orientation of the vertices. Now, vertices, those are the points, right, that come together that we usually put a letter at. So orientation of the vertices refers to the order in which the vertices are labeled, whether we're turning clockwise or counterclockwise, okay? So if we go, we probably should write that down, right? So if we go this way, that is clockwise. I know you don't see a lot of clocks, okay? But if you think of those clocks, there's 12, 1, 2, 3, 4, and I know I'm probably reversing in the video here. Clockwise, and then counterclockwise goes the other way. Counter. Counterclockwise. I don't think I spelled much better, but counterclockwise. Okay? So clockwise and counterclockwise. If that changes, then that the orientation of your vertices is like changing directions, and I'll show you what we mean by that. That means your orientation has changed. Okay? So we're going to label these types of transformations. There's 4 of them here. And then we want to talk about whether their size has changed, got any bigger or smaller, whether their orientation has changed, whether the figure is facing the same direction, or if it's not, or if the letters that we use to name it are going in the same direction, clockwise or counterclockwise or not. So, think of our transformations. Translation, reflection, rotation, dilation. So, look at this one right here. Did we slide it? Did we turn it? Did we reflect it? Create a mirror image, right? Flip it. Did it get bigger or smaller? So if I'm looking here, I didn't just slide it, okay, because its orientation's all messed up, right? And if I look, it kind of looks like we have a mirror image. Like if I were to put a straight line of reflection, a straight line here, right? It kind of looks like we just created mirror images. So when we do that, that's called a reflection. Okay. I don't know if I can erase all these dots here, sorry. You get the idea. Okay. Size. Did it get bigger or smaller? Or did it stay the same? Look like it stays the same, right? The triangle did not get bigger or smaller. Now, orientation of the figure. Now, kind of think of the way it's facing. Like if I'm thinking this is a nose here, right? Is it facing the same direction after we perform the transformation? It's not, right? Again, if I think of it as like a nose or something, it's facing the other direction. So that has changed. What about its vertices? So what do we mean by that? Back to clockwise, counterclockwise. A, B, C. That is moving in a clockwise direction. A prime, B prime, C prime. That is moving in a counterclockwise direction. So the orientation of the vertices has changed. And I'm sorry that I wrote changes here. I guess it really doesn't matter. It should be changed. Same thing here, changed. Okay? All right, so look at transformation number 2. Again, we're going from this figure to this figure. This is our pre-image. This is a kind of review, right? because it doesn't have the little apostrophes. And this would be the image because it has these things. So we're going from this figure to this figure. What type of transformation? Just kind of slid it over, right? And a slide is a translation. Okay, so the size of it. Did it get bigger or smaller? Or did it stay the same? Stayed the same. The orientation. Again, if I'm thinking this is like a nose, did it change this way it's facing? Or did it stay the same? Stayed the same. Okay. How about our orientation of our vertices? A, B, C. See how it's going clockwise? A prime, B prime, C prime. Going clockwise, right? So the orientation of the vertices stays the same. Okay, so good. In a reflection, we know the size is staying the same, but the orientation of the figure and the orientation of the vertices is going to be changed. In a transformation, everything stays the same. Same size, orientation of the figure is the same, orientation of the vertices is the same. Let's keep moving. How about this one here? Okay, well this one got smaller. Again, pre-image, image. And if it gets smaller, the only transformation we work with that gets smaller is a dilation. So, again, if we're just thinking of things changing and staying the same, the size changed. It got smaller. Now, if we again think of this as kind of being a nose and which way it's facing, did it change? Did it flip where it's facing? Did it change where it's facing? Nope, it stayed the same. How about our vertices? A, B, C, A, B, C. And that also stayed the same. Okay, so in a dilation, your size changes, but your orientation of both the figure, the way it's facing, and the vertices, what direction they're moving in, what direction they follow each other in, it stays the same. Okay, so finally, we look at this, kind of seeing that this is turned, right? Or spun. That's a rotation. Okay, now in a rotation, did this get bigger or smaller? We're going to talk about orientation. It's obviously changed around some, but did it get bigger or smaller? Nope, it stayed the same. Okay, now think back to the first page of notes. Remember, translations, reflections, rotations, those are isometries or basic rigid motions. They do not get bigger or smaller. So hopefully this doesn't come as a surprise to us. Now, orientation of the figure. Well, if I think of this part here as being the nose, it's facing a different direction this time. So our figure changed direction, changed its orientation. How about its orientation of the vertices? A, B, C. Clockwise. A, B, C. Notice that's also clockwise because if I continued, remember, we're still moving in a clockwise direction. So even though it's crazy and rotated, the orientation of the vertices still stays the same. In this case, they're both clockwise. Okay? So there's little differences and some similarities to all four of our transformations that we're going to be dealing with. Okay? Again, dilation is the only one that's going to make it bigger or smaller. But make sure you have all of this written down. Okay? The way our shape faces sometimes is changed, sometimes stays the same. And our orientation of our vertices, whether we follow a clockwise or counterclockwise direction, sometimes it stays the same, sometimes changes. Okay? Last thing I want you to do, see how it says summarize today's lesson here? Think about when you're taking your assessment, and I let you use your notes, and you're flipping through each note, trying to figure out an example problem. Jot something down here in your own words that's going to help you remember what this lesson's about. That way, when you go to use your notes on your assessment, you can return to that, and hopefully that'll jog your memory about what we talked about in today's lesson.